Hi. In the last video, I discovered I needed a pretty significant delay here on the, which was it? It was the AND latch signal in order to get the entire circuit working properly, at least in a reasonable timing. And rather than cleaning that up already, I do want to take a look at those timings again and see if there's something that I can do to improve this. I'm not pleased with the additional delay that I've had to add in here. It's rather significant, and I'm not certain it's going to do exactly what I need it to do. I also looked a little bit at the timings again that I had done in my analysis and realized I had some numbers that were incorrect. So I want to walk through those changes with you. Let's get right into it.
Hi, my name is Adam. I'm building a 16-bit computer from scratch. I hope you'll join me on this journey.
So my thoughts related to how the signals would work don't really align well with the way I'd like to see them work now that I can physically touch it. And so what I've done is I've colored the upper portion of the clock kind of in this pinkish color, what have you here. And then the lower portion of the clock signal is in this blue-gray color. And so with that, one of the things that I'm noticing is the latch happens on the rising edge. So as I push the button for the manual clock, I'm getting the rising edge of the clock, and then when I release the button for the manual clock, I get the low edge of the clock signal. And so what that does down here is it gives me absolutely nothing when I push the button, but then when I release the button, it goes low and sets up for the next signal, such that I actually have to push the button to get it to latch again. And that doesn't feel right. Let me show you what I mean. Okay, I've got the CPU reset, and I want you to keep an eye on these LEDs here in relation to the contents of the fetch register here, and then what's on the fetch bus here. So because the address bus 1 contents is 0, the contents of memory is the instruction that's going to come through. So when I push the clock down, the instruction register advances. I get the next instruction contents, or the next memory location contents, on the fetch bus. This is the clock. Happens to look very close to what I'm looking at here. The contents of the fetch register propagate up from the bus up to the fetch register, and that happened on pushing the clock, or pushing the clock button. So we're now at the high edge of the clock. When I release it, nothing happens here to the fetch register. Nothing happens here to the contents of memory on that fetch bus, and then nothing happens here to the instruction register. When I push the clock again, the contents that are going to go into memory, into the R1 register, are now in the fetch bus. The instruction advances up to the instruction register, which is off the screen to the top, and the program counter advances to the next memory location. When I release the clock, so now we've got the falling edge and the low signal, nothing happens here. Nothing changed, but nothing happens. But when I press it again, I now finally get that latch. That feels a cycle or a half cycle late to me. I would, now that I'm actually touching it and got my hands on this, I would much rather see this value get latched on the falling edge as opposed to the rising edge. And so I need to make that change. Okay, so I made the change to the desired signal such that the latch now happens when I release the clock signal. The clock signal itself would then go low. And so now I'll go and make that change on the breadboard. The way I have it wired currently should put plenty of delay in there, but my challenge is it now too much delay? And I don't have that measured in here. I could end up with 100 nanoseconds or more of a delay. I do want to call out that I did make changes up here to the timings. I removed the worst case timings and all the way down the list here. And I did make some changes to several of the LS timings here. And had I done that right to begin with, there's a really good chance I would have had an understanding that the AND latch would have come before the load increment decrement signal. Let me get this on the breadboard and we'll see just how much of that delay I can remove. I'll likely start with no delay and start adding things back in to figure out where things stabilize. Let me get to the breadboard. Okay, I'm zoomed in on this section while I make these wiring changes, and the first thing I want to do is eliminate all of this delay. I'm going to remeasure and redo the delay if it's required. This means now that I can pull these two signals back to their original position, getting those hooked up just on the other side of the NAND gate. And then the input to the NAND gate needs to be, I'm just going to use this temporary hookup wire here, the clock. Now, all of this is eliminated. It's not part of the circuit anymore. And so now I'm going to power this back up and see what kind of an effect those changes have made. All right, let's power this back up. Make sure I'm in manual step mode. Let's reset the circuit. Now, for whatever reason, this is not resetting, and I think that has to do with needing a stronger signal here. So I'm just going to go with it, I think. There it did. So the only thing that has changed really is going to be the AND latch signal. So those are going to impact how the program counter is latched and how the R1 register is latched. So pushing down and holding, I'm getting that latched up there, which is correct. And when I release, I'm now getting the program counter incrementing, which is, it feels much better to me. Again, pushing, my register is up, my instruction is up here in the instruction register. The fetch register contains my constant value. I release, that constant value gets loaded here. And that actually appears to be working quite well with no additional timing problems. Let's get the scope out and measure that. My yellow trace here is hooked up to my increment on the counter chips, and then my blue trace here is hooked up to the AND latch signal here on the latch chips. And so if I turn this loose, turn this into run mode, yeah, you can see that on the rising edge of the increment, the falling edge of the AND latch is happening. Well, that's the falling edge. It latches on the rising edge. So if I go to the falling edge, that's actually a half cycle behind. Am I just totally off my rocker here? No, I'm not. That's actually the way I'm supposed to see this, because the AND latch here and the load increment decrement are supposed to be half a cycle apart. So that's actually exactly what I had set out to do, which is a good thing. Good for me for getting that right. That means that I can now eliminate all of this extra stuff over here, and I will work on getting that done. Well, let me get the scope out of the way, and then I will pull those out. Now, since I'm going to use pliers, I'm not going to do that with power on. And once again, if I reset, instruction down here, looks familiar. Latches here on the rising edge. That latches the new instruction on the falling edge. Push it again, up. This latches on the rising edge and on the falling edge. That latches, and that feels very tight to me. Okay, let me do a little bit of cleanup here and change the colors of these wires, just because I don't want the orange to confuse me that it's hooked up to the actual clock signal. Let me get this cleaned up. Nice. Okay, the next task I want to take on here is I'm having problems getting this to reset properly. And I'm dealing with voltage issues here, and I'm dealing with LS type logic, and with the LS type logic, they've got pull-up resistors. I get a little bit of backbleed of voltage back out onto this line, and then I've got HC related logic here. And so I can't just throw, like I did up here, a pull-up resistor onto this signal. I actually have to provide some isolation from the signal to what I'm driving out here onto the reset, which just so happens to have worked while I was talking. What I have here is an NPN transistor, and I figured I'd give this a try to see how this works. Ultimately, what this is a small signal transistor. I will pull up the data sheet here. And it's labeled as a small signal transistor. Looking at it such that from the top down with the flat towards the back, I've got the collector, the base, and the emitter. The emitter gets connected to ground, the collector gets connected to 5 volts, or at least that's the way I hope it is, because that's the way I'm going to give it a try. And then when you apply voltage to the base, it basically opens the floodgates such that the voltage from the collector to the emitter flows freely. And so these are bulk, and I need to get some pliers and kind of bend these so they fit into the breadboard properly. And so what I'm going to do is I'm going to bend one of these leads out a little bit and then straighten it back out such that it's about 1/10 of an inch apart, the breadboard spacing. I'm going to do the same thing over here. And if I drop this in the breadboard, let's say right here, I should be able to give this a test. How am I going to do this? I'm going to have to remove this reset signal here and remove this reset signal here. And what I want to do is I want to connect directly from here to that spot. So now everything should reset. Let's reapply power here, see if I can get something different. That should reset and latch everything but this. If I put, I gotta go back and look at the data sheet again. Collector base emitter. So if I put on the collector, let's get a little bit longer wire here. Okay, that is the emitter, so that's going to get tied to ground directly. I should just dump these out. This is the collector, so that's going to get tied to 5 volts, hopefully. I don't want that tied to ground. That's going to be a dead short. Now that I'm thinking about it properly. So this then is the base. If I push this, okay, nothing happens. That's horrible. Bringing in the voltmeter here, and I have it on voltage. I do. What I'm looking for over here is when I hit the reset, the power comes up and then it goes back down. Power comes up and goes back down. So that's giving me up to 4.5 volts there. And what I believe I need to do, I didn't think this through before I started recording, is take a 1K ohm resistor and put this to ground. So I now have literally a pulled down signal. All right, so I should have close to 0 volts there. If I push now the button, it comes up to 4 volts. Maybe I don't have, it's not giving me the result that I was thinking I would be getting. But let's give this a shot here. If I take my emitter and connect that over here to my reset, let that run and get a value on it and reset. Yep, that's still not doing what I thought it should do. Make sure I'm in the right point there. What if I take this off? All right, let's pull up the data sheet. Yeah, I've made this mistake before. I needed to double check exactly what my part number is here so that I can go look it up online and get the right data sheet. I have made that mistake before and grabbed the wrong data sheet. 193. Voltage input high has to be above 3.15 volts. That's for 4.5 volts. So I'm coming up pretty darn high. Low is at half of a volt. I'm right, well, 1.35 volts. I'm below 1.35. That's the 54. Need to look at the 74. It's the same voltages. I need to be below 1.35 volt. I am. So that's not going to fix my reset signal. So I guess the question is it a clear signal or is it the and latch signal? Which pin do I want to look at? pin 14. Let me just check and see if I'm actually latching here. Okay, I'm latching there. My AND latch signal is not making it to my board here. The AND latch of a no-op instruction includes latching the program counter. My AND latch of a no-op doesn't include latching the register. That's where my problem is with the reset. So it's all going to depend on what instruction was on the actual instruction that was on the instruction register in order to latch that. This becomes superfluous and a waste. And while I'm at it, I'm going to shorten this up here because I don't need to have that drag all the way over the board. You run that for a minute. Okay, that's doing exactly what I wanted it to do. So as far as the reset here is concerned, I need a more robust reset circuit to get this to latch properly. And I don't know that I'm going to get to that in this video. Okay, well, believe it or not, I have all the hardware I need in order to implement a jump instruction. And I think that's pretty important to double check the timing because of the AND latch issues that I've been chasing. I want to make sure that a load and latch on the program counter does not end up doing something odd and maybe creating an extra instruction in the instruction pipeline here that I haven't accounted for. Let me work on pulling that together and then I'll get a new test onto the EEPROM here and we'll give it a try. Okay, for my test, what I did is I took the same Larson scanner that we used in video 42, and in the middle of it, I put a jump instruction back to address 0. Now, ideally, I'd love to be able to put the label in there, but I don't have the code for that in my assembler yet, and I will be taking that on shortly. In order to support that, in the architecture file, I added 17 different permutations of jump instruction, including jump always and jump never and the conditional jumps. I chose FF as my jump instruction opcode or control word, if you will. And then, of course, with 3 being the register being asserted onto the address bus. Now, of course, that's going to be the fetch register, so that needs to be taken into account. Finally, in the control logic, I added the jump immediate so it can be handled, which loads the program counter and latches the program counter, suppresses the fetch register to pass on to the instruction register, so that's going to pass on a no-op. I am asserting the program counter onto address bus 1 still, and my main bus assert group comes from group 1. Is that correct? No, that's what it should be. So what I want to do is I want to assert the fetch register onto the main bus so that the program counter can latch that. Little debugging right there on the fly. And I'm going to change the sequence of this. Let me get those onto the 5 ROMs and we'll give this a shot. Well, this is kind of embarrassing. I just spent 30 minutes on video trying to troubleshoot a problem that doesn't really exist. Well, I was troubleshooting the wrong problem. And it wasn't until I stopped filming and sat back and looked at the build that I realized what I had done wrong. And that was these 2 ribbon cables here didn't exist. I did not have my connection to the main bus for the program counter. Well, what I've done, I promised the good, the bad, and the ugly. This is definitely far more ugly than I'm used to. I've created a video just of that failed troubleshooting, and I've put that out there. I'm not going to make it a public video, so the link will be up here in the corner and in the description so that if you wish to go watch that fiasco, you're welcome to go do that. But I won't get any public view time for it because it's a private video. So it's neither here nor there. If you watch it, great. If you like that, if you like watching train wrecks, go for it. In the meantime, what I did think about and discover as I was probing around off camera is that I believe I still have a timing problem. So the rest of this video is dedicated towards solving that timing problem and bringing that back in so that my jump instruction actually works properly. Let me demonstrate the problem for you. Okay, so I've teed this up to the right spot here. I've got my yellow trace hooked up to my load signal. That's an active low signal, so it will go low, and then at the point in time that the yellow trace goes high is the point in time that the final value is actually loaded into the counter ICs down here. I've got the blue trace hooked up to pin 1 of the main bus, which is the data that's going to be loaded. And what you'll see is that it is definitively low, but then it goes into a floating, undetermined state in between a high signal and a low signal. And so I've teed up the next instruction. This is my jump instruction here, which is on the fetch bus. I clock it once, and then when I clock it another time and release, and if I zoom in on this, what you have is you have the parallel load going high after the bus goes to a floating state. So with this information, ultimately I need to back the load increment decrement signal up so that it's aligned better with this assert that's going on. Okay, so one of the things I've done here is I've actually added the main bus assert timing. Since this is coming directly off the instruction register itself, not going through a demultiplexer or an EEPROM logic or anything like that, I believe that signal actually happens slightly ahead of all the other bus asserts. And I believe that's throwing my timing off ever so slightly. Parallel load, which goes high, well, really it goes low on the IC, when it's loading off the bus, and then it comes back high. There's a challenge there with that timing in that it goes high after the main bus contents get de-asserted. And because of that, I get values in transition. So I believe the end result is that I need to take this signal and move it back to the high clock cycle, just like I did with the AND latch, in order to get that working properly in conjunction with this main bus assert. Now, to make this change, all I need to do is replace this inverted clock signal here. And so let's flip it into manual mode. Let's reset it and let's see what kind of... All right, that seems to have worked. That worked there. So increment and latch seem to be working well over here. There's my load. That did not work. I kind of expected that. Well, let's see here. What do I have wrong here? Let's try that again. That worked. I'm getting an extra load here of the wrong information on the R1 register. Okay, what happened as a result of the jump? That did not exit. This should have exited and should have been replaced with a NOP instruction. So is this firmware or is this hardware? I made a change to how I represent the load increment and decrement on my signal chart. And what I've done is I've represented any given load increment or decrement signal as being normally high, and it will come low right before the business side of it, which is the rising edge, which causes the increment, causes the decrement, or causes the actual load to complete. Unfortunately, what that does is it also brings into question this AND latch signal now, because the AND latch timing is nearly the same as the load increment and decrement timing. There's not enough delay after the load increment or decrement to handle the AND latch. And so ultimately, I'm going to have to delay this a little bit. I need to delay it so that it's definitively past the load increment decrement, but remains in front of the main bus assert. I need to make sure that I find that happy window that's in there. And I don't want to delay it so far that I compromise my ability to get a really good clock signal, or clock speed, I should say. Let's go to the breadboard. Okay, the goal here then is to delay the AND latch signals coming off of the control IC3 here, or the EEPROM. Probably the easiest way to do that is to just reformat the clock signal that's coming off of here. I don't want to reset it to be the inverted clock, but what I do want to do is I think I want to put in a 74LS04. This is an inverter. I will get my decoupling cap in here and power and ground. And so what I've managed to do over here, just to get it out of my way, is I put it into the clock line here into an unused row on the breadboard, so that I can I'll have the clock input go in here. I will jump to one inverter, jump back to a second inverter. I actually had one too many, so I have 1 and 2 inverters here. Let's try that. And I still see the anomaly down here, so let me try 4 inverters now. So that takes 2 and jumps to 3, and 3 and jumps to 4, and then my 4th one is the output. That took a while to settle and actually start outputting, but I'm still getting that anomaly here. So let's try 6. And hopefully I don't need to get into more than 6. And this is now working properly. I'm getting the correct signals. So let's reset down. 0. Latch is the first instruction. Advances to program counter 1, which has a least significant bit on there. Latch is up and latch is here, so that works. And as I'm stepping my way through this, there's my jump coming in down here. Jump is here. I've advanced the program counter and latched. Here's my jump address here. When I latch and advance, the jump address goes up here, which is correct. My next instruction comes down here. My jump target was properly set here, and I start over. So what I need to do at this point is I need to clean this up here. I also have some address lines down here that I want to clean up. Now that I finally have this working somewhat reasonably, there's 2 things here that I believe it's time to do. One is to start converting some of this back into PCB, and so I'm going to get back into KiCad and start working on that. I've got a couple of utility boards that I'm going to be working on as well. They could be fun little things to help out the breadboard aspect of it. The second is I am not pleased with this clock. There are a number of issues related to switching from manual and automatic mode, and this just is not working the way I had envisioned or the way I really want it to or need it to. So I'm going to do a redo of the clock module. Which comes first? I'm more than likely going to start working on getting those PCBs designed, because the lead time on that will then give me the time I need to take a look at the clock. In the meantime, enjoy the rest of the cleanup associated with the boards here. Already completed, but I'll show it to you now. And thank you. We'll see you soon.